Today, in this video lecture, we will see numerical on design of beam. Numerical is a simply supported beam, 8 meter span, carrying uniformly distributed load, 10 kN per meter, and permissible stress in the material of beam is 30 Newton per mm square. Design the section of a beam if depth to width ratio is 2. This simply supported beam, let us assume that one end is roller and one end is hinge. This first A point support is hinge and second B point support is roller. And span of this beam is 8 meter. And this beam carries 10 kN per meter uniformly distributed load. Permissible stress in the material of beam is 30 Newton per mm square. Sigma permissible is equal to 30 Newton per mm square. Design the section of a beam if depth to width ratio is 2. Depth denoted as capital D, width denoted as capital B, and ratio of this is 2. And problem statement is design the section of a beam. Section of a beam, that means this depth and width calculation. Length of this beam capital L 8 meter, uniformly distributed load denoted as capital W 10 kN per meter. So for solving this numerical, first consider bending moment for this simply supported beam. Bending moment for simply supported beam is WL square by 8. And in this numerical, W is 10 kN per meter multiplied by length is 8 meter and divided by 8. That means 80 kilonewton meter is bending moment for that simply supported beam. Now next, using flexure formula, in this numerical our ultimate aim is to find value of depth and width for the section. Using flexure formula, m by I is equal to sigma by y. Take this I here, I by y. Remember this I by y. What is this I by y? I by y is nothing but the sectional modulus z, capital Z. This m, this sigma, this side, m by sigma, and m is this 80, and sigma is, convert this 80 into Newton mm, 80 into 10 raised to 6 Newton mm, because this sigma is in MPa, Newton per mm square. This sigma is 30. 80 into 10 raised to 6 divided by 30 is sectional modulus. This sectional modulus is 80 into 10 raised to 6 divided by 30 is 2.67 into 10 raised to 6. And unit of this sectional modulus is mm cube. And our ultimate objective is to finding dimensions for that section of beam, capital D and capital B. For calculation of capital D and capital B, Next step is to find this sectional modulus for that rectangular section using formula, sectional modulus formula. Sectional modulus formula for rectangle is BD square by 6. And see, in our given data, D by B is equal to 2. That means this D is equal to 2B. Put this D is equal to 2B in this equation. Two square is 4. B into B square is B cube divided by 6 is Z. Consider this as a equation A. Equation A becomes Z value is 2.67 into 10 raised to 6. Z is 2.67 into 10 raised to 6 is equal to 4B cube divided by 6, and B is 2.67 into 10 raised to 6 multiplied by 6 divided by 4. That means this B value is 158.81 mm. And from this B value, how to calculate D value? See, we have D is equal to 2B. So our D is equal to 2B. 2 into B is 158.81. Therefore, D is equal to 2 into 158.81, 317.62 mm. So we design this beam. See, this B is 159. Let us assume round up value 159 mm. And this D is 318 mm. And this is section of beam. From we have span of beam, we have UDL on this beam, we have sigma permissible, and we have D by B ratio. See, from length, from uniformly distributed load, from sigma permissible and D by B ratio, we calculate this section of a beam, dimensions for that section of a beam. And procedure for solving this is first bending moment using flexural formula, using sectional modulus, we calculate dimensions for that section. Thank you very much.